Welcome to the Cross DOE office panel discussion. And I'd like to welcome my colleagues, John, Allison, Linda, and Scott. And if you go to the next slide, as a reminder, we just discussed the release of the hydrogen program plan, and we coordinate across all the offices. So we have EERE, FE, NE, multiple offices, basic science, ARPA-E, and you will hear from each of those offices. And if you go to the next slide, again, as a reminder, we are focusing on the feedstocks or energy resources that each office is responsible for. So for instance, EERE focused on renewables, covering electrolysis, advanced water splitting, for instance. Fossil, you'll hear about the fossil resources as well as waste and technologies like gasification and so forth. Nuclear is focused on enabling hydrogen from nuclear. So you'll hear about some of the enabling activities. And then of course the cross-cutting offices, so Office of Science and ARPA-E, you'll hear about the fundamental research, the innovation. I think many in the audience are very familiar with the various activities. And so the next slide, again, as a reminder, shows the H2 at scale guiding framework. So again, we're focusing on all the resources. Clean hydrogen is the priority. And of course, safe, efficient, low-cost delivery and storage, and multiple end-use applications. And as discussed earlier, the environmental justice 40 priorities are key, enabling activities such as workforce development and so forth. And so in the spirit of collaboration, we wanted to show all the activities that are relevant here. So with that, thanks again to my fellow panelists, and we will turn it over, the next slide, to John Latinsky. So thanks, John.
Thank you, Sunita. It's nice to be here with everyone. I'm John Latinsky, the Deputy Director for Advanced Fossil Technology Systems. I'll give you a little bit of an idea of where we've been focused this year in hydrogen research and development. Next slide, please. So our real focus is trying to reduce the cost. Hydrogen is, fairly low cost from fossil energy sources, but really focusing on getting to a net zero hydrogen production with utilization technologies such as turbines and gasification for production. Solid oxide fuel cells, obviously are a low cost opportunity for electricity generation once you produce hydrogen or syngas. And then pre-combustion R&D to really reduce the cost so we can improve the amount of CO2 that can be captured from the gasification or reforming processes. So really we focused this year on future R&D, which is basically to get to this carbon neutral net zero hydrogen and gasification reforming technologies. The second major area was the use of hydrogen electricity generation, production of fuels and manufacturing, hydrogen transport infrastructure, large pipelines and what needs to be improved in there, as well as on-site geologic storage. We had many accomplishments over the last few years in hydrogen. I won't go through all of these, but really looking at combustion and reducing NOx emissions, trying to get to this 95 plus, maybe up to 99% capture, with production of basically clean hydrogen, and a very large demonstration program, which I'll feature as well. We are focused on some pre-feed studies for production facilities, as well as several pre-combustion technologies that we've demonstrated at pilot scale. Next slide, please. So this is an image of the demonstration project at the Port Arthur Valero refinery. This has been in operation since 2013, since the last ARRA stimulus funding. We've injected over 7 million tons and produced a significant amount of clean hydrogen from this facility. It's an example of a commercial facility, but there's been a lot of advancements since 2013 and a lot of opportunities, as Sunita said, for the commercial and potential markets for hydrogen in the United States. So in 21, we really focused our efforts on solid oxide fuel cells and reversible systems. We also were looking at trying to achieve 100% hydrogen firing, as well as looking at blends of hydrogen and gas turbines. And then looking at more modular gasification reforming technologies. As I mentioned previously, we've really started to focus much more on the carbon capture and utilization and storage, specifically on pre-combustion capture. And then in our cross-cutting R&Ds, we have some cross-cutting activities in terms of energy storage and looking at hydrogen storage in geologic formations, but other materials, and basically at a very large bulk scale for the bulk generation industry. And then refocusing simulation-based engineering and looking at, how do we optimize some of these hybrid systems that are using hydrogen in gas turbines or other systems. And then finally, we've supporting 2 FEED studies for gasification-based carbon negative power systems, looking at gasifying waste coal as well as the plastics and biomass to produce hopefully net zero hydrogen. Next slide, please. And I just wanted to feature, we did have 2 funding opportunity announcements this year, if you weren't aware, and I'm sure we'll have more in the future as we look to FY22. But we are, hopefully soon going to be announcing awards from the hydrogen FOA that we had, which was broad-based FOA looking at turbines and solid oxide fuel cells and the other technology areas that I mentioned. We also did announce several university turbine research awards focused on hydrogen fuels and the fundamentals of actually producing hydrogen using them in gas turbines and air rotating detonation engines. Again, thank you for your time, and Sunita, I'll pass it back to you.
Great, thanks so much, John. So now we'll turn it over to Allison from our Nuclear Energy Office. So thanks, Allison. Take it away.
Thanks, Anita. Hello, my name is Allison Hahn. I am the Reactor Optimization and Modernization Team Lead within the Office of Nuclear Energy. Next slide, please. To start off, the overall mission of the Office of Nuclear Energy has 4 focus areas: the existing fleet, advanced reactors, the fuel cycle infrastructure, and maintaining global competitiveness in nuclear technologies. It is vital to maintain the existing fleet because it does provide the nation with clean, emission-free power, reliable, firm capacity, and it is less resource intensive than most other power sources. With advances in plant systems, reactors, and fuel cycle R&D, the future of nuclear will provide fast, flexible capacity that can more readily respond to grid load. These reactors operate at higher temperatures, which will provide high quality heat for industrial and chemical processes. Small modular reactors and microreactors also have flexibility in siting that allows the use of heat in established industrial locations. Also, because of their advanced thermodynamic cycles, these designs reduce or eliminate water use. And then lastly, they are designed with inherent safety systems for optimal operating conditions, which all amount to safe, efficient, and low-cost electricity generation. Through these advancements, the United States has the potential to provide sustainable, clean energy for generations into the future and global competitiveness in the energy sector. Next slide, please. This diagram shows the opportunities for integrated energy systems. The overall strategy is threefold. First, integrated thermal storage systems can provide clean, firm, and flexible capacity to accommodate the evolution of a clean grid with greater variable capacity from renewables. A reliable grid with both will require both firm and flexible capacity. Thermal storage allows clean nuclear power to provide that clean, firm, and flexible power to the grid. Second, integrated industrial and chemical plants allow clean power from nuclear to provide power for more than just electricity. Nuclear plants can power the industrial and transportation sectors directly with heat and electricity. Hydrogen is the first opportunity to integrate a chemical plant with the current nuclear fleet, and with the quick responding electrolyzers, the plant can provide peak power when demand increases. We intend to expand chemical plant integration to also include products such as ammonia and synthetic fuels as well. Finally, heat from nuclear plants can be exported for use in industrial processes. Thermal applications include oil production, minerals, wood, cement, district heating. And as I mentioned in the previous slide, advanced reactors will also have flexible siting to locate the reactors closer to these applications. Next slide, please. 4 projects have been selected and awarded by NE and HFTO to begin hydrogen production demonstrations with both the low temperature and high temperature electrolysis. These projects will address electrical, thermal, and controls integration with the nuclear power plant, and nuclear plant operators will learn and become familiar with hydrogen production at their plants. Exelon and Energy Harbor were selected for the first two low temperature electrolysis demonstrations. The example shown here is Energy Harbor's Davis-Besse nuclear power station located in Ohio. The red box is the electrolyzer located in the far corner of the parking lot, and the switchyard is shown at the top of the screen. Excel and Fuel Cell Energy were selected for the first two high temperature steam electrolysis demonstrations. Of course, low temperature electrolysis achieves about 60% efficiency and is a more mature technology. High temperature steam electrolysis, however, is about 80% efficient on an electrical equivalent basis, but is not produced in high quantities yet. The hydrogen that is produced for these demos will supply in-house hydrogen demand, but utilities are also very interested in selling the hydrogen. In Ohio, the Davis-Besse plant may supply hydrogen to our local bus fleet, but other industrial opportunities are located in the area. And then to close out my section, we do have a FY21 funding opportunity announcement co-funded with the HFTO office, again, looking for hydrogen demonstration projects. So we should be announcing those at the end of the fiscal year, so we'll have more updates on that next year. Thank you. I'll pass it back to Sunita.
Great, thank you, Allison. So hopefully the audience can see there's a lot of good activity, demonstrations, getting first of a kind nuclear to hydrogen. John mentioned the great fossil work with CCUS, of course. And so focus on demos and deployment, but I want to emphasize the importance of fundamental science. And so now we'll turn to Linda. We have the long time history working with science. So thanks, Linda, for joining. Take it away.
Thank you, Sunita, and I am pleased to be here today to talk about the research in the Office of Science that supports hydrogen. I'm Linda Horton. I'm the Associate Director of Science for Basic Energy Sciences. So if we could go on to the next slide. For about the last 20 years, BES has had a really strong fundamental chemical and material science research portfolio that is focused on understanding and transformative approaches for hydrogen generation, storage, and use. If you look at the research topics, they cross the full breadth of our programs. There is fundamental material sciences and chemical sciences, as well as the application of our scientific user facilities by the entire community to advance understanding of the fundamental chemistry, materials, and biological processes that are key to innovations in hydrogen. We support research through annual solicitations, including our open annual FOA in the Office of Science. In addition, each year we have special funding opportunity announcements that include topics relevant to hydrogen research. The directions for our program are guided by our strategic planning activities. The very first of the basic research needs BES workshops focused on the hydrogen economy back in 2003. Sunita was one of the key participants in that activity. We subsequently have had workshop reports on catalyst science and liquid solar fuels, both of which are highly relevant to the generation, transport, storage, and separations of hydrogen that are key to advancing technologies. If we could go to the next slide. For this fiscal year, we are planning a roundtable on carbon neutral hydrogen to look at what the priority research opportunities are for in the key fundamental science that's needed to advance the current focus on carbon neutral hydrogen generation, transport, and storage. This workshop will be held in early August with a diverse group of people from our national labs, universities, industries, and other stakeholders. We look forward to having that full report with priority research opportunities, but also the resource document that's being developed together with the technology offices that will be posted on our website that will discuss the status of hydrogen technologies that will be a tool for both the roundtable participants, but then subsequently the entire community. On the next slide, we highlight the user facilities. that are available for everyone in the community. If you haven't accessed the BES or Office of Science User Facilities, you should consider doing so. These include the advanced scientific computing capabilities, the leadership class computers for computational research. For those of you interested in the biological approaches, we have several facilities supported by our Biological and Environmental Research Office that look at genomic sequences, systems biology tools, and other things for that could be applied to biological hydrogen generation. And of course, for the characterization and nanoscale science, the BES X-ray, neutron, and nanoscale science facilities provide both synthesis and characterization tools. If we look at the next slide, we have a singular example of how everyone works together to enable progress in this field. In the first panel on this slide, you see the fundamental science that was enabled as part of our Solar Fuels Hub program, the JCAP project, working with our light sources and the computational resources to really understand what's going on at the interfaces of semiconductors and electrolytes, looking at the protective layers, and doing modeling to understand the multi-physics, multi-scale modeling required for hydrogen generation. In the middle panel, also done by JCAP, was the prototyping of 19% efficient solar fuel generators that took place as part of the JCAP project that was then picked up as part of the EERE hydrogen project for further assessments for benchmarking and then moving it to commercialization through the various programs that are supported by EERE. This flow of the science to the to prototypes to the technology offices for further development and then eventual commercialization is one of the key benefits of this cross-DOE panel and collaboration that we have supported. And with that, I will turn it back to Sunita. Thank you.
Great, thanks. Thanks so much, Linda. And so hopefully folks in the audience can see again that synergy, coordination, a cohesive approach. So we'll end the panel with ARPA-E, and I'll introduce Scott. And I'm sure there are many in the audience also who've been working on ARPA-E funded projects, those high risk, high impact potential areas. So welcome, Scott. Turn it over to you.
Thank you very much, Celia. I'm Scott Litzman. I'm a program director. And I'd also like to say that on Wednesday at 10 a.m., Grigory Soloveichik is going to be presenting an overview of some RPE's programs in more detail. So I definitely encourage you to check that out too. Next slide, please. RPE operates differently than other parts of DOE. Our programs tend to be shorter term and they're really program director driven. And we have a program development lifecycle from defining potential programs to competing in funding opportunity announcements to actively managing those programs and then handing it off. And if you advance one more, please. You can see that there are relevant programs to hydrogen fuel cells sort of across the spectrum here. So at the very top, some of these programs that are nearing the end, they're handing off to other parts of DOE or industry are Rebels, which is intermediate temperature fuel cells, Ionics, which is partly about alkaline exchange membrane systems, Refuel, which is focused on carbon neutral liquid fuels. Those are nearing the end of their time at RPE. There's a program called Integrate, which is fuel cells hybridized with gas turbines. That's more sort of midstream in the course of the RPE program. And then there's a few programs that are just getting off the ground, getting started, such as REACH, which is fuel cells and electric systems for aviation, and also Refuel IT, which is more of a testing program for carbon neutral liquid fuels. But you'll notice there's sort of a blank space on that top right around definition. And this is where we actually could use help from attendees at the AMR in helping RPE program directors think about what these programs could look like. Now, next slide, please. Now, one example is one of my colleagues, Zach Fung, is considering a potential program in the area of stationary hydrogen storage. Now, it's early, he's still thinking about it, but very much could use feedback from this community. He released an RFI, I think maybe late last year. And if you go to this URL at the bottom, prior to our open 2021 solicitation, we released a series of webinars talking about areas of potential interest. And Zach has a short webinar talking about how he's thinking about the stationary hydrogen storage space and trying to carve out an area that might not have been explored as much. So if you're interested in that, I encourage you to check these out. And I encourage you to engage with Zach, as well as anyone else RP who might be thinking about hydrogen fuel cells, because like I said, it's really program director driven. And I think engagement with the community sort of helps spark what these future programs could be, because it's not a given that RP works in this space. It's really driven by the person. Next slide. And I think to make that point, unlike other parts of DOE, RP program directors and tech market advisors are term limited by definition. So we're here for a few years and then we rotate out. And because of that, we're always hiring. And so if you or people in your network are interested, we encourage you to reach out to the email below or to myself or anyone else at RP to discuss your interest in a position. Program directors and tech market advisors are hiring essentially all the time. Fellows are usually new PhDs. That's done only a few times a year. But again, it's a very different model, and we're currently always using sort of new people to help us define what those programs are. And I think there's a lot of opportunities in the hydrogen fuel cell space, which we'll talk about in a few minutes. But with that, thank you very much and looking forward to more engagement.
Thanks very much, Scott. And thanks to all the panelists. So I think if we can, if everyone can turn their cameras back on, we'll go to the discussion part of it now. And again, I think it's really, I want to emphasize the all hands on deck approach. So if we're going to meet our climate goals, we really need to accelerate progress. And for all of you, we coordinate very closely among all of us at DOE, and you'll see projects actually presented throughout the week. Scott mentioned as well some posters and so forth across offices. Several of you, I think, are getting funding from multiple offices. So what we'll do now is basically do some Q&A, and I will ask the first question. We'll start with John and we'll just go in order. But given the stakeholders in the audience, so today we have from fundamental research, science, all the way to deployment. So we have industry, universities, national labs, we have investors, developers, again, very diverse end users, utilities. Again, it's very broad, and there's just so much interest in hydrogen now, just in the last couple of years, especially. From that point of view, for all of our panelists, what are the highest priorities that you'd like them to focus on from your office's perspective? So again, giving the time frame we're in now with hydrogen, our focus, our priorities, low cost, clean hydrogen. How do we really accelerate progress, meet the president's climate goals that he's laid out for us, the EJ goals and so forth. Again, maybe just a quick, 1 or 2 minute response. We'll go, sure, there are many in the audience thinking, what are the highest priorities from each of these offices' perspective?
Yeah.
So we'll start with John.
Yeah, thanks, Anita. It's a great question. And I think from our point of view and the perspective of how we are going to contribute to the administration goals of decarbonizing the electricity sector, we're really looking at, how do we reduce the carbon footprint of the hydrogen itself that's being produced. So a lot of our focus is basically, increasing the rate or the efficiency of the carbon capture systems associated with gasification systems. But we're also looking at, these gasification systems as essentially kind of a platform technology. We have been focused so much on coal in the past, but we're really starting to look at other feedstocks like waste and biomass and plastics. But as you said, it depends on the technology that we're looking at and what stage of research. We're going to be funding everything from early stage research to, feed studies for some of these systems, because we know that, some of this technology is ready to be deployed, but it hasn't been deployed at large scale as integrated systems. So we may be doing some work in that space, but we're still going to be improving the efficiency of these systems with new materials and process intensification and some of the great research that's coming out of RPE and science that we're going to hopefully integrate into our programs and hopefully accelerate over the next 10 years to help meet these goals of decarbonizing the economy. So it's hard to answer in 2 minutes, but I would say it's probably the entire spectrum, and it's going to be difficult. But I think we're up for the challenge, and we're looking forward to working with the stakeholders here to help us advance the research.
Great, thanks, John. And so Allison, from the nuclear perspective too, the top priorities, again, there's so much we can work on, but from the audience's perspective, can you say something about your main priorities in the office?
Of course, and we're very similar to John in SE and applying all of the technology that's being developed in the fundamental offices and in industry as a whole. But for us specifically, it's ensuring there is a growing market for hydrogen by deploying technologies to produce products such as ammonia and liquid fuels from hydrogen, which could be a substantial market for hydrogen in general, and then also for nuclear power specifically. Within NE, we are conducting R&D to address the existing fleet's economic challenges, while also supporting multiple advanced reactor designs, some of which could be deployed within the decade. And we expect to be able to respond to this hopefully increasing demand for hydrogen with these clean energy assets. So just ensuring that the hydrogen demand continues to increase, we'll be ready to stand by and support that.
Great. And now that we have some nuclear projects, again, looking at baseload nuclear, how that gets integrated with variable renewables, I think all of that is really exciting, first of a kind work. So with that, we'll go to Linda. Again, same question in terms of priorities.
Thanks, Anita. Basic Energy Sciences is a very broad program. We fund lots of foundational research. But if I were to say what our priorities are, it is for the really innovative and discovery-oriented research that will translate to impact in the technology space. We will have some priority research opportunities identified by this workshop, the roundtable that we have planned, but we are also looking for input from the community as part of the RFI that this group will be publishing, that will ask you for where are the areas that you think that the science just isn't there, that is the lack of understanding is preventing you from making progress. So we are also looking for input from you to help us identify what those priority research directions should be to really accelerate the field towards the carbon neutral hydrogen vision. Thank you.
Great, thanks, Linda. And as a reminder for the audience, the RFI that was announced earlier this morning, that's a DOE-wide RFI, so it includes, really looking for input, across the board. So thanks for reminding everyone about that, Linda. And so Scott, finally, again, what are the priorities from your perspective, relevant to the hydrogen and fuel cell and the broader stakeholder group here?
Sure. So we're always looking for, pretty out of the box, high risk, high impact ideas. Right now, we're going through an open solicitation, which we do every 3 years. We get lots of ideas, and we hope that once we make the selections, that there will be some new ideas in the area of hydrogen fuel cells that could be interesting going forward. One specific thing I'll highlight is a recent paper by Nestor Sepulveda and coworkers at MIT and Princeton, and they looked at the design space for long duration energy storage, which is one of the things I'm interested in managing the RB Days program. And what they specifically called out were two things that they could really think could help reduce the cost of decarbonization in these technologies, which is lower capital costs for energy and higher discharge efficiency. They found in their models that was most sensitive. And if you think about hydrogen, geologic storage has the potential to be very, very low energy capex. There's a lot of possibilities there, but I think there's also possibilities to improve the discharge efficiency. There's been a lot of good work in making that better, but what they show is the higher and higher you can push that, it substitutes for more older assets in the grid, and it reduces the cost of decarbonization. So it really ties together the cost of performance with the impact on our energy system. And I think finding new ways of getting that low energy capex and increasing discharge efficiency could have a really big impact toward all these goals we've been talking about.
Great, thank you all. I guess, believe it or not, half an hour is just about up. So hopefully the audience got a good taste of the collaboration, the coordination, addressing everything that's going to be needed from basic science all the way to deployment. Earlier this morning, I also brought up the Loan Program Office. So the main message is stay tuned. We have a lot more planned, and please keep up the good work. We're really all counting on you. to pay attention to, all of the activities, and we look forward to your progress. So now we are going to break for lunch and then be back at 1 p.m. Eastern to continue the rest of the AMR. So please join me in thanking the rest of the panelists. Thanks again for joining. So we'll sign off now, and we'll see you back here at 1 p.m. Eastern. Thanks, everyone.
Yeah, thank you.